All right, determine the coterminal angle. Do you guys remember what coterminal means? Landing in the same position as another angle, right? Okay, so this is my angle. How do you move a revolution forward on a circle to land in the same rotation? It's a 360, but this is in radians, so it's a 2 pi. So we're gonna add or subtract a 2 pi, but we're gonna try to match it as a fraction. So if this has a 5 on the bottom, we're gonna do this as a 10 over 5. Does that make sense? Instead of 2 pi, 10 over 5 is still 2 pi. So for instance, if I went up by 2 pi, so if I added a 10 pi to this, it would be 11 pi over 5. But is that answer in this domain? No, it would be too big. So I actually have to think about going down a circle, backwards a circle. So think about 1 pi here. If you went down by 10, you're at negative 9 pi over 5. If you went down another 10, uh-oh, I think that's past where I want it to go, right? Because I can't go more than negative 2. So this is too small. So there's one answer to that. Okay, so sometimes it'll say state all the coterminals, so there might be a bunch in a set domain, but this time there was only one. Okay, what is the domain of this graph? So again, there's so many questions that pertain to logs. What do we know about a result position on a log? It has to be positive in this zone. Right there, that result has to be positive. So what do we know about x if we have to stay positive? How do you write something about x? X has to be greater than 4. You have to stay greater than 4. Not equal to, because then if you're equal to, you're 0. Right? 4 minus 4 is 0. 0 is not positive. There's 3 types of numbers: negative, 0, positive. 0 is not either one of them. Does everybody know about this as a graph? A log-shaped graph, right? The asymptote's there, the log shape will go that way. Okay, but that's the big idea. That has to stay positive, not 0. It has to stay positive. Okay, sinusoidal question. Okay, given this equation and then the graph of it here, we're trying to get the x coordinate right there. Okay, so I need to talk about my period stuff. How do you find the period of a sinusoidal curve? There's a little thing you have to memorize. How long does it usually take to go through a circle? 2 pi, which is like going a domain. What do we do with a domain? Divide by b. Same as our transformations, right? 2 pi over b. Do we have a b value in this equation? 2. So 2 pi over 2 means that pi is a cycle. So what do you know about my movement from the P to the Q? Is that a complete cycle of moving? Going from P to Q, would that move me through a cycle?
Half a cycle.
Half of a cycle. So from here to here is a half of a period. So what is the x value going to be? If this is pi, then this is? Pi over 2. So thinking about it continuing, there would have been a point there, and then we would have actually started right there, because 0 to pi is a cycle. Okay, verify that this is true for the equation at x equals 5 pi over 6. So I'm going to plug in 5 pi over 6. Okay, so this is unit circle stuff. You do not have a calculator, remember, on this question. After, what were we at? 14 questions, we lost our calculator privileges. Okay, so 5 pi over 6. That is right there. So, do you remember this is the cos value and this is the sine value? Cos is x stuff, sine is y stuff. So we can replace cos with negative root 3 over 2. And we can replace the sine stuff with a half. Okay, who can tell me what 1 subtract a half is with mental math? Just a half. And who can tell me what 1 plus a half is? 1 and a half. Can you write that as a just mixed, not a mixed fraction, improper fraction? 1 and a half is 3 halves? Okay, what do you do with fraction divide by fraction? Flip, multiply. Twos cancel. Okay, we are so close. We're trying to show you that these are the same numbers. Does anybody know what to do? This is the side that's not mathy. Is there something we can do with this? Do you remember it? It's a grade 11 tool. Rationalize the bottom. How do you get rid of a root on the bottom? multiply by root 3. But if you multiply the bottom by root 3, you have to multiply the top by root 3. So 3 root 3, that would make, and when you do a root 3, it cancels to be a whole number 3. Okay, so this is verifying. We just showed you. It says verify it is true, so it is true, but we have to show that it's true. So there we go. Okay, I'm going to do this a different way just because we need more practice at this. We're going to do a trig proof because we can conclude if we show a trig proof is true, therefore it is true for any angle. So that we've verified it that way. Okay, because there's a specific strategy. Who knows the strategy when you see this one for a trig proof? If you don't see it and can't do it, you're going to get nowhere. So what is the strategy for this one? It's a weird word. It starts with a C. The word conjugate, does that mean anything to you?
You got it.
Okay, and it doesn't matter. You just have to pick one of these binomials. So it doesn't matter. Should we start with this one? Okay, so I'm going to go... Sorry, I'm just going to use this space over here on my paper. Okay, so what is a conjugate? It's the same binomial, but an opposite sign. So if this has a plus, then this would have a minus. Okay, when we work with this, we're going to FOIL it. But there's something special about foiling with conjugates. Always get canceled, like a difference of squares. This and this will always be opposite and get canceled. So if I flip it, it would be 1 subtract sine squared. Now what? What's your next instinct here on the proof? 1 subtract sine squared. That's what I'm looking at right now. Difference of squares. Yeah, we just came from that. So we're not... Replace it with something? Yeah, that sounds good. So that's me looking at my formula sheet, right? Wherever my formula sheet went. I don't have my formula sheet, but do you remember which one? Cos squared. Okay, looking good. What do we do now? Algebra, something math algebra now. Cancel. So if we cancel a cos, that would be gone completely. And cos squared would just be a cos x. And look at that, we did it. Okay, so if you do this, we have to now conclude. We proved it for all angles, thus we've proved it for that. Yeah, a proof means that no matter what angle you put in there, it's always going to be true. So this way proves it for just the one angle that we were given, which is probably what you were supposed to do, but this proves it for all angles, which in the long way proves true. Okay, given that we have a factor, determine the value of k. So you can pick two methods. you can kind of go towards the remainder theorem, or you can go towards the synthetic division. You pick. I'm going to be doing both just to show you. Okay, so remainder theorem, synthetic division, doesn't matter. You're picking a kind. What's the root number? Doesn't matter which method you use. Both methods have to use a -1. Okay, so here's some remainder theorem stuff. I plugged in a -1. Here I synthetic divide it with a -1 out front. And because it is a factor, what's the purpose of a factor? On the remainder theorem, the remainder is 0. Synthetic division, you got to end with a 0. Okay, so this is just algebra here. So I'm going to go -1 cubed is negative. I don't have a calculator. Remember, you're not touching that. -1 squared is +1, but then I have to subtract it. -k minus 8. Negative, 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 so that's -10. Okay, synthetic division method. Bring this down. Times add times can't add. So now I have to backtrack. What would I need in this block to make 0? 8. What would I need down here in the times are making 8? This times that makes 8. -8. What plus 2 is -8? -10. Okay, so I showed you 2 different ways. Obviously, I got to the same answer. It should be the same answer. Okay, given this function, which is a radical, we're going to describe, so we have to use words, how to use the transformations to determine the domain of this function. Okay, here's the first thing. As a radical square root of x, what's the domain on this? Because there's restrictions about square rooting. What can't you do when you square root? You can't square root negatives. So the original function has a domain of, if I can't be negative, what's the domain on this? Can't be negative. So I have to be greater than or equal to 0. The transformation affecting x are So do we have any B or C that changes anything with X? Remember, this D won't affect anything with X, right? Do we have any B's or C's that are going to change my X stuff? We're moving left 2. So we have to move our original domain left 2. Okay? B, if a B is negative, right, that also really changes our domain. Given this graph, state the equation of the vertical asymptote of the reciprocal. Okay, so you have to think about what happens with reciprocals. An asymptote is something that's undefined. An asymptote is on the graph because it's an undefinable spot. So how do you make a number undefined? What's going on with a number if it's undefined?
What's divided by 0?
When it's dividing by 0. So f of x is like the fancy y. So where is there a height of 0? On this graph, where is there a height of 0? At -2. So we would have an asymptote here if we flipped our height. And it says state the equation. So you need something equal to something. So how do you write it as an equation? What's this line on a graph? How do you make up and down lines? X equals or Y equals? X equals -2. Okay, exponential equations. So we kind of had a summary last time. If we have exponential, we usually log both sides and separate. Okay? But you don't have your calculator on this question, so there should be a bigger hint. This is a special case. You have no calculator, and if I wanted to log both sides, I would need my calculator with that. So I can't do that. Does anybody know the other strategy specifically on this special case? Same base strategy. Remember that? Okay, 16 and 64. What kind of base would they have in common? 2. So how many times would I have to repeat 2 to get to 16? I'd have to repeat it 4 times. 2 times 2 times 2 times 2 is 16. Yes, you're right. 4 also works because 16 is 4 squared. And 64 is 4 cubed. Yep. Okay, so we actually found you could have done it either way. You can repeat it with 2's. Or it works also with 4s. 4 squared is 16, 4 cubed is 64. Okay, so you need to make sure you know your exponent rules. You don't have to do this both ways. I'm just, if you picked one or the other, you do what one you have. So what do you do in a scenario when your equation looks like this? What's the idea? If the bases are the same, conclude exponent equals exponent. Please don't cross them off like that you're canceling. You're just concluding that. I had to deduct somebody that made a cancel. It's not really canceling. It's just a different idea. Okay, no calculator for that question. Completely factor this equation. Okay, we were already told one of the factors was x plus 3. So you're going to synthetic divide. One of the factors is x plus 3, so the root number, negative 3. There are no gaps. Okay, you guys know how to synthetic divide, so go ahead, bring down, times, add. You should get a 0 because it told me so. Okay, so what is this as a polynomial? Now all those numbers mean what? 1 x squared minus x minus 2, right? That's how you go about that. Cubed divided by an x is an x squared. Okay, so you have to write this in completely factored form. Please don't forget important things like p of x equals okay, so this divided by this is this. So I want to write factors, so I want to write the timesers. So this times that. So this times that is the cubic, right? This divided by that is that, therefore this times that is that. I'm not done because it says completely factor, so this you need to do by hand because it's just a simple trinomial. Common mistakes, people forgetting p of x. Another common mistake is that people forget to bring this x plus 3 with it. You should know cubed was my original. I need to make sure there's 3 x's when I times. So if you forgot that, that's a red flag because you only have an x squared as a times total. Okay, sketching a graph of a polynomial. So first thing is how many timesers do I have with x? I have an x to a 4 altogether. What's the idea of the shape? My idea of the general shape is a W. Where are the x-intercepts? -1, +2. This is a doubled. So that's going to bounce. This is doubled, so it's also going to bounce. The y-intercept, so if x is 0, if x is 0, what do I get? Hello? Yes. Yep. Miss Tana. Miss Tana. Okay, I'm getting a 3 times 1 times +4 equals 12. Okay, so I know my intercepts. I know where my arrows need to end up. So I'm going to bounce, and then I'm going to bounce. And I'm going to deduct myself a half of a point. I didn't do any labels. Make sure you label. As long as you have some label on the x and some label on the y-axis. You need both. Make sure you have some kind of labeling on each axis. Okay, we have a composite function. So we're going to be putting the g into the f. So we're going to put this into the f. Okay, so I did the plug-in. What happens with the square root squaring? Cancels. So here's my equation, comma, what's the domain? What do you know about x? Is there any restrictions to here? Is there any restrictions on here? Yeah, there's a restriction with radicals. What do you know about this value? You can't ever square root negatives. So if I'm can't be negative, then x has to be positive or equal to 0. I'm going to go a little bit further because I think there's lots of questions about also, can you graph this? So what is this shape as a graph? All the things you've ever graphed, which one is this one?
It's a line.
It's a line, and it would be down here at 4, and it would be going staircase 1. But do you notice what I would do? I wouldn't keep going forever on that line. I would just stop right there. Okay? Does that make sense? I would stop my line because I can't have x pass up. Okay. Determine an equation. So this is a what kind of graph? Give me a word. What is this? Is it a polynomial? Rational? Radical? Log? Is it an exponent? What is it? It's a radical. You got to know the general shapes. I gave you that pink paper. It has like the big ideas of each one. Okay, so this is kind of what we're doing. We're doing a radical. Let's see where we want to put stuff in. What does a normal radical do? Okay, so a normal radical starts 0, 0. A normal radical does 1, 1, 4, 2, right? Okay, so let's talk about what we're doing. This one has started on the coordinate 1, 0. So I need to move, somehow I need to move right 1. So that's going to have to get changed, something on the C. Okay, and let's talk about our pattern. 1, 1, 4, 2, 9, 3 is normal. Let's talk about this pattern. Okay, it has gone left 1, up 2. It has also gone 1, 2, 3, 4 left and up 4. Can you see some things? So what's happening here and here? Negating. So which letter does that change? It's a B. So we have divided by -1. So I need a -1 there. And what happened to this column? My pattern got times by 2, which is a times by 2 is on the A. Okay, another log question, and it has something to do with the exact same thing we've had 4 times on this exam. What do you know about y-intercepts? What is a y-intercept on a graph? It is where x equals 0. So if x was 0 on a log result, what do we always know about log results? They have to be positive. So if x was 0, would that work? No. Okay, so explain on your exam. What do you have to do as soon as you see the word explain? Words. So how are you going to write that in words? The y-intercept is where x equals 0, which means the result of a log is 0. And the result of a log has to be positive. Okay, so the y-intercept was x equals 0. If I put the 0 in there, now I'm not positive, not going to work. Okay, please make sure you're not using vague stuff when you're writing. Okay, 2 more pages, we can do it. Okay, on this one, you're going to use the unit circle. You have 0 calculator right now. Okay, so what do? I go to negative pi over 3. So I'm on a unit circle. Negative pi over 3 puts me right here. What do you do to find the sign? You find the sign by taking the y. So I'm going to grab the y value. So negative root 3 over 2 squared. So it told me to square it there. Plus, how do you go to 17 pi over 6? That is not on the unit circle. It's me doing a bunch of swivel till I get there. Okay, so watch me swivel. I'm going to go there, which is 6 over 6. A full circle would be 12 over 6. If I went another half, what's that number? 18. So I wouldn't go that far. I'd land there. Does that make sense where I land? So I'm looking at this spot, and it asked me for the cos value. So what do you grab when you want the cos? You grab the x. Okay, and then times by the secant. So pi over 6, I go there. And secant is a flip. What is secant a flip of? Cos. Cos is the x value. So this, but I take it flipped. So 2 over root 3. Okay, so those are all the trig values. Now you got to do the math. So if I square, so root 3 becomes 3, positive, because negative makes positive, over 4. And then plus, so BEDMAS, I times those first before I add. What happens with all these things? Cancel, 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 cancel. -1. Some of you might be able to do this in your head, but I'm going to change this to a fraction. So -4 over 4. Okay, this is a rational because it's a fraction. So we got all of our rational rules. Non-permitted values. Is it an asymptote or a whole? Degrees. That's as soon as I see rational, that's what I'm thinking about. Determine the coordinate. FYI, you're going to need a coordinate. So you need a x comma y for the whole. So how do I find a whole? I'm looking for something that cancels. So this is what I need you to do. I need you to factor the top. So what kind of factoring style would you use there? GCF work? So x out. So on this bottom here, what is the number that I'm not allowed to be for x on the bottom? I can't be 0, right? So my whole is going to be 0, comma. And now I am going to do that cancel. So after I cancel, this is what I get. And if x was 0, this would be -3. Okay, 2 more. We can do it. Then we're done. Okay, we're going to sketch the graph of h of x by adding 2 functions together. So I'm going to go x, an f column, a g column, and an add column. Where does our domain start? What's the most left I can go where they both exist? -2, -1, 0. And you know what I can do? I can technically go on forever because they both go on forever, so that it would keep going. Okay, so I got some f heights. That's that linear one. And some g heights. Okay, so these are the coordinates at the end that I'm graphing. So -2, 0 would be a coordinate on my final graph. So to me, it looks like a pattern. I'm seeing a quadratic shape. And I am missing something. An arrow, and it has to be on the right, but not on the left. Okay, because look at our domain again, -2 and then forever. -2 forever. Okay? All right, last one on this exam. Trig question. Okay, question for you. What is cosecant the flip of? Sine. And which letters is sine? Because you don't have these on a formula sheet. Y over R, so I'm flipping that, right? So you're really cute, X-rated, thank you, excellent. That might be helpful for you. But this is the sine stuff flipped. Okay, let's talk about Astica. Where am I? So if cosecant is negative, sine is negative, where? Where's sine negative? Bottoms. But I also know that the cos trig value is positive, so that would be on the right. So my conclusion is this is going to be in the 4th quadrant. And I'm going to draw a triangle. And you know what I'm going to do before anything? I'm going to put pluses and minuses on there. What do you think about this side? Plus, down, radius always positive. Because this is tricky because there was a -4. That's not the R value. The R is just 4, and then this Y is actually the negative. Okay, super quick. Pythagorean theorem. This squared is 16. Subtract, what's root 7 squared? 7. 9. Is that square rootable? Yes. And does anybody know the letters I'm going to look for with tan? Thank you. Excellent. So I want the Y over the X.